Today we're taking notes on elements, compounds, and mixtures. So scientists classify matter into three categories. These three categories are elements, compounds, and mixtures. And we've talked about elements before. We talked about elements that you find on the periodic table. So let's write there. Let's write that here. These are found on the periodic table. So elements contain only one type of atom. They cannot be broken down into simpler substances by either physical or chemical means. And what that means is physically breaking something down would be like breaking it, tearing it, washing it, something that doesn't really change the makeup of the element. Chemical means might be something like burning it or separating, but using chemical means. But it cannot be broken down no matter what. It can exist as either atoms or molecules. Atoms means it's a singular, molecules would be like two of them of the same one joined together. So here are some examples of what elements are, and you can add other ones. So you can have sodium, we've talked about, Na. You can have O and 2. If you have two parts of oxygen, that would be like a molecule of oxygen. You can have fluoride, you can have boron. Another one that sometimes is seen together is H2, where you have just two hydrogen, and that's a molecule. So if you have just sodium might just look like this. That's what you've got, an atom of that element, just singular together. So for example, this might be sodium. Sodium doesn't really look like that, but this would be like a structure. To differentiate one that, say, like this would be boron element might look like this. So again, it's singular, it's on its own. You can't break it down any more than it already is. It's just there. And a molecule, and again, this is not on the test, you don't need to know this, but it's good to know because this is when you have like two oxygens joined together. But that's considered an element. Okay, so I think we're probably pretty comfortable with elements. We've talked about these before. Okay, a compound. Let's go ahead, let's talk about what a compound is. Compounds are not going to be on the test, but we're going to talk about them next unit. So a compound can contain atoms of two or more different elements. They are bonded together in a specific ratio. Okay, the one that comes up right away, so it contains atoms of two or more different elements bonded together in a specific ratio. The first one I think of is H2O. If I were to have H3O, that's not water. This is a very specific ratio, 2 hydrogens to 1 oxygen. Another one that we've talked a lot about is, we use a lot for examples, NaCl, 1 sodium, 1 chlorine. It's a specific ratio. Another one that you'd know a lot from last year is C6, H12O6, and I hope you all know that that is sugar. Okay, these also, these can be broken down into simpler substances like elements. They can be broken down into elements. However, by a chemical means. So it's nothing that we are going to be able to do in our 8th grade science lab, but not by physical. So it's not like I can pick them out, break them, rinse them off. I can't break down water. I can't turn it into a hydrogen and oxygen. In a science lab you can. The same with NaCl. I can't take some salt and turn it into a chlorine and a sodium atom. If you take it to a lab, you can. Has different properties than its component of elements. Okay, what that means, and we've talked about this in class, how the compound NaCl is table salt, but sodium is a reactive metal and chlorine is poisonous gas. So this is a reactive metal, poisonous gas. You put it together and you can eat it. So these properties that they have are different than when it's combined. It makes a whole new substance. That's what that last one means. So here's examples of what they would look like. So we could say that, okay, we've got your two different elements, like let's say this is NaCl. So I should say that maybe this was Na. Okay, water would look like this. You would have your one oxygen, it kind of looks like Mickey Mouse ears, and your two hydrogens. One oxygen, two hydrogens. One oxygen, two hydrogens. And I cannot separate these. You cannot separate these. But if you took it into a chemistry lab, then they could be separated. Okay, I think it'd be a little complicated to do our C6H12O6. Okay, this is what is going to be on your test. Mixtures. Mixtures contain two or more substances of elements or compounds. They are not bonded together. They are not bonded together. So this is what you need to know for the test, what a mixture is. It can be separated physically. It retains many of the same properties of its components. So examples that we've done in class is, and what we've talked about on our graphing, is we've talked about sugar water. When you take sugar and put it in water and mix it, that's a mixture. I've not chemically put anything together. When we watched the video, we saw how the sugar molecules, compounds, the sugar, because sugar is a compound. The sugar just mixes with the H2O. They don't chemically combine. And I can separate them. And the way that I could separate sugar water, let's use this for this. Sugar water, I could evaporate the sugar in the water. I could let that water just disappear over a few days and I'd be left with a sugar. And what sugar water would look like, I would have my H2Os, and then I have like a sugar crystal, and those would just be mixing together. Okay, so another one would be like, say, another mixture could be like a salad or a pizza. This could be something I could just pick apart. So let's draw a salad. So here I've got a salad, and in my salad I've got tomatoes, I've got some lettuce. This is a weird looking salad. What else would I have in my salad? Ooh, I want avocado. So I want some avocado slices in my salad, and that's going to look an awful lot like my apple slices I want. And there goes the light. But I can pick those apart. That's a simple thing for me to take apart. On a molecular level, these would all just be like completely different looking things, but they're not attached. I could even have like a compound in here. but they're not attached. They're just kind of all floating there together. Another mixture, let's say, let's do another example of, let's do if I mix together salt and sugar, and I mix that together in a bowl. It would look an awful lot alike, but the way that I could separate that, like Cinderella did, so your salt crystals are going to be a little bigger than your sugar crystals. So your sugar crystals would be teeny tiny. Your salt would be a little bigger. They look the same when they're all mixed together. But if you had to, you could probably put them in a strainer, the little holes, and you could strain them out. So you could separate that by straining them. Okay, so let's do magnesium, a metal, is burned in the presence of oxygen. It makes magnesium oxide is produced. MgO, is MgO an element, a compound, or a mixture? Explain. Well, MgO, I know it's not an element because there's two, and an element has to be of one type of an atom, and an MgO is two. So it's rather going to be a compound or a mixture. Well, since it's two and they're, I can't separate those. I can't separate magnesium oxide. So I know it's not an element. And I know that I can't separate them. Mixtures I can separate. So it has to be a compound. Because it is two elements bonded together.